In this part of the video, you're going to be responsible for watching another video by Professor Dave. Professor Dave Explains. You're going to watch that to learn a bit more about organic compounds and why carbon is so special. I'm going to give you a brief overview of that, but then I want you to watch this video here to get a few more examples. So, as you know, organic compounds are compounds that are carbon hydrogen based, but primarily carbon based. So you do need to see the carbon hydrogen bonds there, but carbon is the main focus. And why carbon? As living organisms, we are carbon-based organisms. That means a lot of our molecules that make us up, like our phospholipids and our cell membranes, those little phospholipids that look like this little lollipop thing here, those are made up of these big carbon hydrogen chains. Our proteins are made up of a bunch of carbon hydrogens, but lots of carbons. Our carbohydrates, our nucleic acids, our DNA, RNA, they're made up of a bunch of carbon-based compounds. So we are carbon-based life forms. And so what makes carbon so good at essentially creating us, of making us up? What makes it such a good building block for organic chemistry? Well, there's a few things, but the first one is its tetravalence. So the special feature of carbon that makes it unique and really useful in organic chemistry is tetravalence, which basically means it has four valence electrons here, 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 and here, because it's in group 14, so four valence electrons. And what that allows for is four bonds to form. So carbon can form a whole bunch of bonds. It can form four single bonds, for example, like this. It could form two double bonds, so essentially four lines. It can form a triple bond and a single bond. It could form a double bond and two single bonds. So it just goes to show that because of its tetravalence, carbon is able to bond to is able to form four bonds. So it could form a variety of different types of bonds, whether that be double bonds, triple bonds, or single bonds. But it could also connect to many things. It can bond to many things. So that leads essentially to its versatility. Because it can form so many bonds, it's able to bond with a variety of other atoms. So it can bond with some O, it can bond with some N, some halogens, some phosphorus, and other atoms. And that gives diversity in the molecules that you can make, which means that you can have a lot of different functions filled in by the carbon-based molecules that are used in your body. And as I mentioned, the tetravalence gives another point to versatility. It allows you to make single, double, or triple bonds. But another interesting thing that you might not know yet, or you might not be quite aware of, is that carbon compounds don't just have to be chains. They don't have to be these chains of carbon and hydrogen. I'm not drawing the hydrogen in, but I'm just drawing the carbons. They don't always have to be linear like this. They could also form rings. So you can have these little carbon hydrogen ring compounds that form. They can form sheets as well. But the point is that they can form a variety of different structures. You'll get some more examples by watching this video here and also taking a look at the images over here. So you can take a look at the great variety that carbon leads to in terms of molecules because of the idea that it can form four bonds. You can have chains of different lengths. So here we have ethane with a 2-carbon chain. Here we have propane, a 3-carbon chain. Here we have butane, a 4-carbon chain. On those carbon chains, you could have branching. So you can connect a branch of carbon off of a main chain over here, which leads to more diversity in the molecule. These different structures, these different chain lengths, they have different functions because the different structures read or treated differently within the body. We can have multiple bonds. So double bonds, for example, as you see here, and you can have triple bonds as well, and you can have single bonds. And then you can also have structures where carbon connects with other carbons to make some ring structures. So you can see that over here. So that just speaks to the volume of the diversity that carbon brings to the table, and that's why it's such a good atom to use in organic chemistry. That's why our bodies have likely evolved to use carbon to form living things, and not just our bodies, but just all living things that have membranes and that use biological molecules. So be sure to watch the video Professor Dave explains, understand why carbon is so versatile with its tetravalence, and provide examples of how versatile carbon is. In other words, can you provide examples of carbon being able to form different types of structures, different types of bonds, and bonding to many different things? In the next video, we're going to take a look at organic families and functional groups. It'll be a brief introduction to it. And the rest of the unit is essentially studying the different organic families and the functional groups that make those organic families different from other organic families.